Good afternoon, ladies and gentlemen, boys and girls. We are busy with organic chemistry. We will do the organic reactions in this session. And a little bit, I will show you also on Siavula, what a powerful instrument is it for teachers and children to exercise themselves in the organic. So about later on that, on the Siavula, let us continue with the organic reactions. Here on the screen you see the addition reactions, unsaturated to saturated. This is addition reaction. So addition reaction is where reactions where atoms are added to the organic molecule. A double, triple bonds break open and the new atoms are added to the atoms on either side of the double or triple bond. We can add hydrogen, a halogen, that is group 7, chlorine, bromine, iodine, hydrogen halide, of all water. In addition, reactions, alkenes or alkanes from an alkane chain as a product. So we add the hydrogen, in this case a halogen, and in that case a hydrogen, and if they at the bottom also water. But I want to show you, like in this case I put the water in it. I put hydrogenation, the adding of it, and there's a on the left hand side is the elimination reaction. So that's just the opposite of the other one. The addition reaction and the elimination reaction. In this one side I add it to, and the next side I take it away, the substance. For instance, like in this case I add hydrogen, there I remove the hydrogen. So I can remove it also, and this is the elimination reaction, dehydrogenation. Hydrogenation and dehydrogenation. So I have a double bond there, I add a hydrogen, I get a saturated alkane there. Alkene from a hydrogen plus an alkene, I get an alkane. Here I have an alkane, I remove the hydrogen, and I get an alkene plus a hydrogen. And these are conditions of the reaction. You had to know that. They must be in the presence of a catalyst, platinum, nickel, or palladium, and in this case also dissolved in non-polar solvent and needs to have that catalyst. So both is the same. You must just remember the one you subtract of you add on, and the other one you remove it. Okay, let's just look to the halogenation, where I add an X of a chlorine, fluorine, a halogen. I add halogenation, I add a halogen. In this case, I add to also alkene, alkane, and I get a haloalkane. Here I dehalogenation. I have a haloalkane, I took away that and form alkene and a halogen gas. That can be chlorine, fluorine, bromine. The reaction condition is an unreactive solvent. In this case, no water is present. The reaction conditions is very important also. You must mention that also if they ask you a reaction. The halogenation, hydrogen of a halogen, halogen, fluorine, fluorine with a hydrogen. So I have a hydrohalogen plus the alkene or alkane, and I get, in this case, I get two products, one with the X on the second of the halogen on the second one, and the one with the halogen on the second one. And there is Markovnikov rule playing around there. The one is a major product and the other one is a minor product. So this will be the major product. And let us see what is the major product. The hydrogen atom will bond to the carbon atom, which has a greater number of hydrogens bonded to it. So the rule, the hydrogen atom will bond to the carbon atom which has the greater number of hydrogen atoms to it, the hydrogen bond. So there's a chlorine and a hydrogen bond. So there's two, which one have the most hydrogens, so that is that one. You have two hydrogens, the first one, so the hydrogen will bond to that, and the next one of the chlorine of the halogen will bond to the second one there. That is Markovnikov rule. Okay, so hydrogenation, dehydrogenation, there we took it away. Also, there's also Zaitsev rule, and also a major and a minor product is forming there. So just keep it in mind. Normally they ask you what is the major product or what's the minor product. Mostly they will ask you what is the major product in this case. Okay, let us look to the next one. That is hydration. Add of water to it. So I have water there plus an alkene, and I get a major product also there. I think that it's the very same rule of Markovnikov in the presence of sulfuric acid or phosphoric acid in the heat of steam and water reactant. So that's the conditions there, and it will form a major alcohol, 2-propanol or 1-propanol there. Dehydrogenation, the removal of the hydrogen. I remove that hydrogen from this hydrogen formed there, and I produced an alkene also. Sulfuric acid is known as a dehydrating agent. So you take away the water with the with sulfuric acid as a catalyst there in that case. Okay, let's go to the next one. Okay, why is this one not opening? Just give me a moment.